presentation. Welcome to panel 4. The title of the panel is United States-Portugal Technical Cooperation.
Thank you very much, Mr. Chairman. It's really a pleasure to be here in this very important event of the WavEC, which is in fact doing a lot for fostering all the renewables, and in particular, of course, those related to the ocean. And it's my pleasure to be here today, particularly to speak a little bit about this great cooperation between, of course, the US and Portugal, which is the MIT-Portugal program. So basically, the MIT-Portugal program, so it's a cooperation between universities and companies, Portuguese and the US. There is a broad spectrum in the MIT-Portugal program. So basically, we are a program which runs 4 PhD programs: engineering, design and advanced manufacturing, transportation systems, sustainable energy systems, and bioengineering systems. I would claim that ocean-related activities can be found in all of these areas, in fact. But of course, today I'm going to speak a little bit more about the sustainable energy systems program. So all of these programs, what they do is that we tend to attract different students from all across the world and to have them working in Portugal during 1 year. So they have 1 year of classes. They are jointly taught by professors from the Portuguese universities, and we have universities that cover all the country, so as a partnership. And in fact, one of the main objectives of the program when it was launched was to bring the universities together, so to promote cooperation between the Portuguese universities. So the program has 1 year of classes in Portugal, and then typically the students spend up to 1 year at MIT during part of their PhD program, jointly supervised by 1 Portuguese and an MIT professor. Recently, for example, at IST, this program on sustainable energy systems has also been offered as the Portuguese component of the KIC InnoEnergy EIT PhD program. In fact, I don't know if you are aware, this European Institute of Technology, so they have a focus, one of the focus is on energy, so this is the KIC InnoEnergy, and we are the Iberian pole for this program, particularly focused on renewables. Professor Sarmento is very much involved in this, so this is an important area. Now, if we have the 4 PhD programs in the MIT-Portugal program, since the last years, we decided to join, in terms of research, energy and transportation. So they are now merged in an area which is sustainable energy and transportation systems. And then we have an area of material design-inspired products, and the bioengineering area is mainly focused on regenerative medicine, so stem cells and medical devices and all of that. So, in terms of energy, we are really focused on a systemic view of the energy systems. So we want to develop solutions, basically where renewables can be a solution of the overall energy system. So that's basically our focus. And this, of course, involves looking at the demand, so making flexible demand, demand-side management, smart grids, including transportation solutions, and then, of course, to a lot of emphasis in renewable energies. So, for example, one of the focus and applications was recently in sustainable cities. So the city as a demonstrator of the integration of renewables and the demand-side management, transportation, etc. So aggregators, all these things that you know about and that we are, of course, very, very keen on developing. So, we look at this in this perspective, so which is an holistic perspective. So we want to focus our students in improve energy efficiency, promote demand-side management, promote pricing mechanisms that give the right signals to the market, and of course, overall, we want to make renewable energies more attractive to the people. So to create the conditions, basically, by which the energy renewables variability is better dealt with. So this is, of course, very relevant. And we also have students, for example, that study wave energy and others that look into specific technologies, but with this overall broad perspective of the energy systems, and this is why all the MIT-Portugal program is on systems, so sustainable energy systems. So rather than one or two technologies, but rather looking at these all together. So we want to look at the people, how can we provide conditions for each one of us to be an actor of the energy system. So I will not bother you a lot with this, but just to give you the flavor of what we aim at. The MIT-Portugal program is a big program, and this is maybe one of the main characteristics, and of course I need to bring some numbers, some figures to prove it. So we have now, as of now, 525 PhD students, which I think is an amazing figure anywhere in the world, particularly in Portugal, plus 111 PhD graduates that did already graduate and are working in Portugal and all over the world, so in the different fields. We also provide students, we also provide executive master students, so we graduated a lot of executives, say, which normally came from companies and then do the executive master. We have students from 44 countries. We have 30% of the students enrolled in the program are foreign students, much more apply to the program, so then those then engage in the program. These involve about 270 Portuguese faculty, 70 MIT faculty. And of course there are now, I need to say that a major focus of the MIT-Portugal program, and areas like the wave energy are relevant in this arena, is on entrepreneurship. So the idea of course, of partnering with MIT is very much to bring this idea of the innovation ecosystem into Portugal. There is a competition which is run by ISCTE, which is BGI. I believe that many people know about it, which has already run 5 editions. And what I can say is that by working on this area, we have already created over 300 jobs, secured more than 20 million euros in financing of the startups. So this is really an important thing. But of course, this is a program between universities, and there are 8 Portuguese institutions offering PhD in association, and we have a large number of industrial affiliates committed with the program and partnering in the research projects. This diagram is important for us. I will try to explain more or less the diagram. So MIT is the left sphere, and the Portuguese universities are the right spheres. What I want to highlight here is that this is the co-publications between people from the different universities. And these clearly show that from the 2001 to 2007, so this is the first phase of the program and the second phase. So in the second phase, the collaborations between the Portuguese universities, so which are these bars that link the right spheres, are much stronger. So this is very important, and we are very proud of this. So the program really served the objective of, as our chairman was mentioning, promoting collaboration between the Portuguese universities. And more than that, I would like to say, for example, in sustainable energy systems, we have not only engineering but economic faculties. So we bring these together, and this is really the innovation of the MIT-Portugal program. And of course, it's easy to claim that the country is now more mature in this type of cooperation, and particularly in this entrepreneurial characteristic of our students. These are some figures which are, again, I believe you will agree, important. So we have received to date more than 2,700 applications for the PhD programs, which is, I think, it's very impressive. So here you see the evolution on the years. There are 2 good news here. So the total is increasing. So to this year we have over 450 applications. And the second good news is that the most wanted program is energy, so which is the green one. So there is a lot of people applying to the energy program, normally over about 150 applicants per year. More than 50% of the applicants are foreigner, and we are admitting about 23% of the applicants, which is a good figure, an excellent figure for the Portuguese number. So 1 out of 4 students are admitted. So we have very high quality students, and we enroll about 80 to 90 students per year. and we have already graduated 111 students. So, this is a very confusing picture, but again, I will not go through it in full detail. But this is just to say that the students are exposed to these entrepreneurial characteristics of the program all across the different maturity phases of the entrepreneurship education. So first they have some classes in which they need to develop some ideas on how to transform an idea in a product. So this is done in the first year during the classes. So this is what we call the E-teams. So, and then once they do this, they can go into, and some did very well, for example, in the MIT 100K competition at MIT. And then they may enroll in this BGI, Building Global Innovators competition. And these, if they do this, they go along all the process of mentoring, of exposure to the Portuguese ecosystem, and then they go to the finalists. 20 teams can go to MIT, where they are exposed to mentors and investors and angels and all the ecosystem. It's an amazing program during 2 weeks, where they really are intended to get fundraising activities and to launch their startups. So this is a characteristic of the MIT-Portugal program, which is important. And of course, the message here is we welcome people in the area of the ocean technologies, and they can, by enrolling the program, become exposed to all these activities. There is also well, other figures we could present about the outreach of the program, like, so there are all the page views of the internet website and all these things. So MIT-Portugal have been present, widely present in the communication, and nowadays more in the web. And I would also like to highlight this program that we are offering now. So this is a new feature. So any company here in the audience, we would welcome you. So we have started the MIT-Portugal program. So the MIT is an MIT program where they send their students abroad to work in a company, for example, during an internship. And by having started this program, we are now inviting Portuguese companies that want to welcome some MIT student for a while. We have some cases of success, particularly companies, Portuguese companies that started activities in the US and that are very interested in having MIT students that spend some time here, know the company, and eventually they can become, workers of the company in the US and develop activities. So this is now open, this is brand new, and that as it is brand new, during this phase we are fully financing this, so even the company needs to pay very little or eventually nothing, depends on the type of cooperation we establish. So I think this is just a very brief description of the MIT-Portugal, so its features. So basically what I would like to say, we welcome students, we welcome companies, we welcome the companies to share with us our research activities, and of course we would like to be partners to empower and outreach. So, and we are very, very much engaged in renewable energies and for sure in ocean energies, and not only energies. So please count on us, and we will be very, very happy to partner more with the WavEC and associates and the Portuguese ocean community. Thank you very much.
It's yours.
Thank you.
Go on.
Well, this is going to be mostly pictures. I tried to keep the words down to a minimum, so just relax and enjoy the pictures. This is a picture of where I work. It's just outside Boulder, Colorado, and you can see the wind turbines. We test a lot of turbines there, and you can see the mountains in the background. The wind blows right out of that cut in the mountains, and you can see the peaks up there. Those are just big vortex generators that give a really good bumpy ride for the turbines. So that makes it a good test site. It's pretty pathological. We can destroy most turbines if they're not done to the right specifications. I'm going to talk, kind of give an overview of the DOE program and some of the laboratory work, not just my laboratory, but some of my colleagues and other folks we work with. And I just want to point out that the Department of Energy in the States is trying to do technology advancement. They're trying to test the devices. We're trying to look at the resource, and we also are worried about environmental and markets. And the kind of bottom line is cost of energy. So that sort of drives our thinking and everything we do. Okay, wave resource in the U.S. It's all yellow on this side of the screen, which is the East Coast. There's not much wave energy there. It's all over on the west side. So that's where the focus is. There's quite a bit in Hawaii and also even more up in Alaska. So it's West Coast, Alaska, and Hawaii. And that's also where the tidal, 90% of the tidal energy is up in Alaska, not much in the States. I want to talk about a project I'm working on with, NREL's working on with my colleagues at Sandia. It's a joint project between the two labs. It's called WECSIM. It's a wave energy converter simulator, and it's kind of this is a block diagram of it. We just released a working version of it, and it's available at the website on OpenEI. So if anybody's interested in trying your hand, it is a research code. It's not polished. It's not done. It's been released. It does work, but I'm sure there are bugs and some things that need to be improved. It's open source, so we want folks to contribute to it. It's a drag and drop, and it's done in MATLAB. So you do have to have access to MATLAB, but it makes use of a boundary element code, which is WAMET, to get the hydrodynamic coefficients, and you can do your performance. This is a typical one for a wave energy converter we were working with. The connection with Portugal is last week we had a meeting in Washington, D.C., and one of your later speakers, Marco, was over to help plan an international code comparison under the auspices of the IEA Ocean Energy Systems. So we're trying to get everybody together who's got a good ocean code and benchmark them against each other so there'll be great reliability in terms of, if I use this code, I know its answers are comparable to perhaps some other code. We'd also like to benchmark with test data, so we've got a ground truth in there. So that's a work in progress, but it's a cooperative effort that hopefully will be international in scope. The DOE wanted to look across a spectrum of wave devices and wave and tidal devices. So there's a couple tidal devices. We called it a reference model project. It's not the best, it's not the worst, it's sort of a typical device. And what we were looking for is how well do they perform? What does a first order cut at the energy, cost of energy look like? The answer to that is not good for any of them. But anyway, we tried to look at them. We tried to look at what might be the pathways for improvement. We ran models. We did some testing in the wave tank in this particular case, and we tried to benchmark our results. One of the labs that was involved, and actually the leader for that project, was Sandia Laboratory. And here's a kind of a smorgasbord of some of the work they're working on, which is they're trying to do some simulation of tidal devices, experimental validation of some of their wave array prediction, tidal current. They actually went into the water tunnel at one of our labs in the States at Penn State and have been running some subscale models in there, and they've been looking at coatings and materials. Another area they're looking at is wave modeling. You can see the pictures up here. You can see a tidal model here. and they're looking at sediment transport, acoustics, and they've even got a hydrokinetic test site that they put on canals or in ditches to look at the performance experimentally. My friends at PNNL contributed a couple slides. You'll hear more about this, another area of cooperation within the ocean energy systems. It's TETHIS, and I won't talk a lot about it except to say that it's a database on environmental impacts, and I'm sure Teresa will talk more on that in a minute. But it is an area of cooperation between us. An interesting project that was done between Sandia and Pacific Northwest Lab was they came up with a collision model for a southern resident killer whale in Puget Sound, and basically they ran the whale into a turbine to see what kind of damage it would do. I was somewhat skeptical that they could find all the material properties, but they were able to, from a dead whale, to recover elastic modulus and bone structure and elastic properties to do a simulation. Kind of on more recent DOE initiatives, there's out there on the street, or going to be a solicitation for something called WEC Prize, Wave Energy Converter Prize, to compete devices in a wave tank. They've just selected the administrator for this, but you want to stay tuned. If you're interested, they're going to test devices in the Naval Research Tank, which is a large-scale wave tank in the States. We're also doing, you've already heard about some field demonstrations in Hawaii at the WETS test site, which is a Navy waves test site, and there'll be a couple contractors chosen to test out full-scale devices in this particular test site. I want to switch to offshore wind. NREL also works in offshore wind, and this is kind of an overview summary of basically the entire program over the last few years. So it covers several years here, but you can see the type of money at the bottom and the test facilities, addressing market barriers, looking at drivetrains, innovative technology. And some demos in the water. And I'll say a bit more about those, but here's the map of the U.S. offshore wind resource, which is, you've already heard today, it was 4,000 gigawatts, which is enough to run the country about 4 times over. So there's no shortage of offshore wind resource for the U.S. Most of it is the best wind resources on the west coast. That's where the waves are. You'd guess there must be wind somewhere around there. Here's the 3 major types of platforms, floating platforms, and they're stabilized in the water different ways. This one is a spar with a big counterweight down here. You got this huge thrust load from the rotor. Wind turbines, the thrust on the rotor. It's only a little bitty rotor, but it basically has the same drag coefficient as if that was a full disk up there. So the thrust loads tend to overturn it. You can gravity ballast it. You can use a float like the wind float. And this one is got tension legs, an idea stolen from the offshore oil industry, and you can use the legs, tension legs there to stabilize the platform. Here's the projects that were going. It was done a 2-stage effort. There were 7 awards made. They just down-selected to the 3 finalists. One is Dominion. This is a bottom-fixed platform. Fisherman's Energy. And so those 2 projects are going forward. And then you heard from Ala about the wind float, which is a deep water floating platform off the west coast. Just again, to sort of tie things together with Portugal, we're bringing this technology back to the States to demonstrate it in deep water off the west coast. I want to tell you about another new project. We're taking a look back at wind, and we're talking about a program they refer to as A to E, atmosphere to electrons. And they're taking the perspective of not just the turbine, but the whole wind farm. And the idea is to tie together the companies, basically private industry, national labs and universities, the DOE program, other federal agencies, and they've even got an international cooperation to look at what's happening in wind plants on a fairly large scale. And I'll have a picture to show a little bit later of some of the ideas that people are thinking about. We're losing some of the energy in the wind plant. We'd like to recover it. You've got weather models tied to wind farm array models, directly tied to wind turbine dynamics models. So it's coupling across multiple time scales and multiple size scales. So it's a very challenging simulation effort to look at both experimentally and analytically what's happening. I want to talk about a bit about, just a couple seconds about what my lab does. And so I'm going to see if this movie will play. Oops, must be on that. There we go. This is a large-scale simulation, a large eddy simulation of the flow into the wind farm. If you got really good eyes, you can see this turbine here spinning. You can see the wake from the turbine in front of it, see the blue parts of the low wind wakes. Down here in the box is a simulation. And as the wind direction changes, you can see the turbine output and performance change as a function of time. They're not only looking at simulating the turbulence with large eddy simulation, then they have to simulate basically what's happening dynamically at each one of the arrays, each one of the turbines, and they're looking at the dynamic loads, structural loads in the turbine, and they're looking at the shed vorticity and wake effects in that wake. So it's a very challenging, large-scale computation problem that runs for days. Next slide. Oops. Okay, I'm just about done. A couple slides. We do a lot of testing at the lab. We have a lot of physical capability. And this is a series of drivetrains that we've tested within the wind program. These are all wind drivetrains. We're about to test our first generator for a wave energy converter. But we've been doing this for about 20 years now. And so we have a pretty good capability. 3 different dynamometers at different scales. We've tested blades. I like the picture when I was young and had black beard and lots of hair. We'd stack sandbags on it to test the blades. And now we've got resonance test devices to simultaneously excite both the flap mode and the edgewise mode simultaneously to get both edge and flap response. You can see the evolution of the testing techniques and what's been done over time. And I'll leave it at that. I'd like to acknowledge I stole slides from all my friends and colleagues. So they were all contributors, and I put them together in sort of an eclectic show. So thank you very much.
And then the University of Lisbon. So if you are ready, Marco, you can go on.
Okay, thanks. Well, good afternoon. I will share this presentation with my colleague Teresa Simas. I will focus the collaboration with the US. We started a few years ago in the numerical modeling area, and Teresa will focus the environmental collaboration. Well, the 4 institutions from the US we have been more involved in collaborating is the Sandia National Laboratories, NREL, WEDGE and Principal. WEDGE and Principal power 2 companies, NREL and Sandia 2 national laboratories. There's more collaboration, but I think these 4 are the most relevant ones. So with Sandia, we have been working together on the development of wave-to-wire codes. What is a wave-to-wire code? Basically, it's a software tool to simulate the entire chain of energy conversion from the wave device interaction to the electricity feeding to the grid. Here you can see just an output example. With these codes we can assess motion and velocities in every degree of freedom, eve, pitch, sway, doesn't matter. Also structural loads, and ultimately the instantaneous power. So these are the more relevant parameters to evaluate the performance of a wave energy converter. Then with NREL we have a collaboration a bit different. This collaboration is some kind of code collaboration. Is in fact something like we want to establish now for wave energy converters, and Bob just mentioned a few minutes ago. We did it for wind. This basically is a joint collaboration with more than 15 countries and probably 30-something codes. It's a forum of discussion to optimize and to validate and verify codes to simulate the dynamics of floating wind turbines. Basically, the call of this project is OC4, Offshore Code Comparison Collaboration Continuation, is led by NREL, and we start this collaboration for the OC3 with the previous one, and we were deeply involved in this OC4, and also OC5 is the next step. We are also collaborating with the US. This is just an example of what we are doing. So is basically no more than a meeting, a discussion, and then put the results on top of the other, comparing all the codes on this sector, and check the results. It's not exactly a certification process, but it's something like, it's the most closest to a certification we have nowadays. And basically we can see that for this particular example, which was the detection of natural frequencies of a floating wind turbine, is basically this one quite close to the wind float, but it's not exactly wind float because the turbine is in the middle. We can see a very good agreement with some exceptions like here, but anyway, this is just to discuss and to improve the codes. Then with companies, we have been collaborating with WavEC. WavEC is originally a Spanish company, but they have a branch now in US. WavEC is developing a wave energy converter. What we did with them was to support the design, the geometry optimization, all things related to hydrodynamic modeling and site selection, and ultimately developing the codes I mentioned before, wave-to-wire codes, to predict the energy production. And then ultimately we are being also involved with economical analysis of this concept. Here I have two more pictures, but there's only three here. This basically is the missed pictures was some kind of a picture from the construction of the device. This is a device they built and they deployed in Canarias, WavEC. This is the deployment, and this is the operational, the device during operation. So what they are doing now is to do exactly the same type of project, but in the US, to install a device in Hawaii. Okay, I have the pictures here. These two are the development or the fabrication phase. Then, with Principal Power, we did some academic. This was not done more than a pure academic exercise. What we did was to analyze the performance of the wind float with two oscillating water columns attached to the front pillars. This was just an exercise to measure the improvement or the increase in power production and the effect of this increase in power production, the effect that this increase may have on the LCOE. We did this study, as I mentioned, an academic exercise, but we had quite promising results from this study. Now, I will give the stage to my colleague, unless you want me to talk about this.
Good afternoon. Well, I would like to have a lot of experience like Marco presented, but I only have one, and I only have a few slides to present. And the work that I'm going to present was already mentioned by Bob, and it was not, of course, in numerical modeling, but this time on environmental effects of marine renewable energy. This work has been made in the context of Annex 4 project, which is part of the ocean energy systems dedicated of the International Energy Association that is dedicated to these issues. And the leader of this Annex 4 project is PNNL, the Pacific Northwest National Laboratory, PNNL. It is a national laboratory part of the US Department of Energy. And the Annex 4 goal was to examine the environmental effects of all marine renewable energy and environmental research studies in order to guide the sector, the ocean energy sector, in terms of good practices, environmental monitoring methodologies, the best methodologies adapted to this kind of project, and so on. The other main goal was to disseminate information to marine researchers, regulators, and developers. So our job, we have been contracted by PNNL to develop three main areas of the work program in Annex 4. The first one was to develop or compile a master list on environmental effects. The second one was to provide information to load a database, and we made an exhaustive data collection on environmental effects based on tidal and wave energy projects, which was the context of the work. And finally, the last part of the work was to select, or regarding the all information that we have collected, try to understand and select what were the relevant environmental issues and try to prioritize this kind of problems. Well, this slide is for the master list, so we try to follow a methodology that was already referred this morning by Belinda Button, based on stressors and receptors. So stressors are related with the features of the project, the ocean energy projects, and receptors are the components of the ecosystems. So firstly, we had to identify both of them, and then based on that information, we tried to address effects to each of the stressors receptors pair. We came out with a table with 66 rows, which is a very exhaustive table, and to complete the job, we tried also to assign mitigation measures and monitoring methodologies that were currently used for each of to each of the effects. This list was presented by WavEC in a workshop in Dublin, which had the participation of around 150 participants from US and Europe. And I think the audience was composed by developers, by researchers from US and Europe, with regulators too. So this audience was a real benefit to the discussions because they were very productive. And at the end, we came out with a list of data gaps or important issues that should be the priority of our analysis within the Annex 4 project. So at the same time, we were also required to collect information from projects installed at sea in terms of monitoring methodologies and results of that monitoring activities. So we made an exhaustive collection of data regarding all wave and tidal projects we could find information. We had to contact developers if the projects were already in the phase of sea trials to get from them the information on monitoring and results. So basically we made a metadata form that with project identification, licensing information, and also the key environmental issues that were collected during the monitoring activities. So we came out with a very long list with that number of projects for wave and tidal developments, which was amazing. So this is my last slide, just to try to highlight what were the most important aspects we collect from this collaboration within with US. So during all this process, some differences between the licensing processes between here in Europe and US arise, and of course they are also related with the environmental requirements in each of the continents. So it was important to understand and to identify these differences and also to learn with them, because this diversity could benefit our conclusions on best practices or best methodologies, and try to address these important environmental issues. Another important aspect that was highlighted during this collaboration was the different policy regarding data sharing. In US, everything seems to be public, and in Europe, there's more constraints regarding this data sharing. And it's good to know that we are sometimes doing the same research or the similar research, but in US it's much easier to get the results than here in Europe sometimes. And finally, and maybe the most important point, is that we could identify a number of topics for further collaborative research. And this is important because we identify that collaboration, several activities were prepared and are supposed to be scheduled for the next 2 years. WavEC will continue to work with PNNL in the context of Annex 4, and there are a number of workshops, webinars, and international conference at the end of this two years period. But we still don't know how we are going to get the funds to go to all these workshops and conferences that are planned, and we would like to have even more activities of collaboration, because we found it very benefit for both groups. Maybe we can raise a crowdfunding, and I have to speak with Stephanie Thornton to give me some tips. Thank you for your attention.